VR course coordinator, respected faculty members, and students of VSIT. I, Akshat Dayal, would be your host for today's introductory session on game and XR development with Unity. Today, we'll dip our toes in the amazing and vast world of video games and VR, with Mr. Vishal Pandey taking the helm of today's session. Mr. Vishal is a research scholar at the Computer Science Department of IIT Roorkee, pursuing a PhD in an exciting interdisciplinary field of cognitive and computational neuroscience. His work and research interests include a confluence of state of the art technologies like virtual and augmented reality, machine and deep learning, and brain computer interfaces. He has worked as a research fellow at the Defense Research and Development Organization, Delhi, for 4 years after graduating from the University of Delhi. His work at DRDO was focused on developing VR-based training and assessment modules for the Indian military and paramilitary services. He has been an instructor of courses in game development, virtual reality, and data science domains, and has multiple publications in top conferences and peer-reviewed journals. He has also recently started his entrepreneurial journey with a company that aims to address mental health care issues in India. Today, he will be guiding us through the wonderful world of Unity development and extended reality. But just before we start, I would request all participants to turn on their cameras for a group picture. So as soon as possible, everyone.
Yes, all participants, please switch on your camera and coordinators take the screenshot. And also all of you need to, take one screenshot with your photograph while attending the session. It's necessary to put the same in the feedback form at the end. So keep one of your photograph while attending the session.
So if the coordinators have taken the image, please let me know.
Just take a gallery view screenshot. Aditi, both of you, have you taken?
Yes, sir.
Okay, thank you everyone.
Thank you everyone for your participation. Now, without further ado, today's session is bound to be an experience, and I, for one, am filled with excitement. So, without further ado, I shall hand the charge to Mr. Vishal Pandey. Over to you, sir.
Thank you. Thank you, Akshat. Thank you, Dheeraj sir. Uh, Very good afternoon to everyone. Let me just share my screen and then we'll start. Is my screen visible?
Yes, sir.
Yes, sir, visible.
Okay. All right. So thank you for the introduction, Akshat. I am Vishal Pandey. I am currently a research scholar at the Department of Computer Science and Engineering at IIT Roorkee. Previously, I worked at DRDO in Delhi, where my research has been focused towards enhancing and evaluating cognitive descriptors or doing cognitive training for the Indian military and paramilitary services. My research interests since I've started in the research field have been in the field of in the domain of virtual reality, machine learning, and brain-computer interfaces. And I'll share some of the projects of how these three things come together and what kind of research opportunities exist in this domain, as well as what other opportunities and what other domains are there specific towards VR and AR. So for today's session is basically a precursor to uh, a course on development of XR with using Unity. So XR is basically extended reality, where basically we can talk about virtual reality, augmented reality, or mixed reality. So today we'll be understanding what is the difference between these things. So we'll start with an introduction of XR, then we'll see some projects. Some projects would be student projects that students from WIPS or other universities and colleges have built while they have done their internships with me at DRDO or IIT Roorkee. And some projects will explain how a confluence of multiple things, multiple fields combine together and basically build this exciting new cutting edge field of neurotechnology. Then we look at what development tools are actually required for developing in XR. Then we'll talk about the content of the course that we are planning. And then finally, we'll take some queries. So to start with, virtual reality is very common now. A lot of you have already seen the recent hype around metaverse and Facebook changing its name to Meta. So recently, everything from XR has shifted to Meta and metaverse. But to understand where that comes from, we need to understand what the difference between VR, AR, and MR is, and how the recent hype has marketed or changed these meanings to different things. So, if we try to understand the meaning of VR or virtual reality, any computer generated three-dimensional environment is a virtual reality. So it does, like, generally, if you when you talk about virtual reality, you think that you're wearing some headset or head-mounted display, and that is generally associated with virtual reality. But if you look at the base definition of virtual reality, it is basically any computer-generated three-dimensional environment, which basically means that even if the environment is not in an immersive head-mounted display, even if it is on a desktop based scenario or on your mobile phone where you have a distance with the environment, even then it is virtual reality. So any mobile game that you've played or any desktop games that you've played, like GTA or PUBG, in a technical sense, in an actual sense, they are all VR. So the crux is that any environment that can be explored or interacted with by a person can perform different activities in that environment. Like in the video that you see, this is a very famous game called Beat Saber, which is one of the most popular games since the start of VR, and till now it is still the most famous and the simplest game that you can see, like you can find out there. It's very simple. If you go back to the origins of it, if you so this is an immersive version of the game that you see in the video. But like if you want to see where it originated from or how what the perspective was before this immersive version, then you must have seen games like Piano Tiles on your phones, which was basically the origin of this kind of game where you kind of hear some music while you're uh, clicking on or tapping some things, and the music goes along with that. So that is how the evolution of virtual reality has taken place. We have just shifted the perspective from like having some things at a distance from our eyes to actually being in that environment and trying to change the way that we interact with the environment. So this is virtual reality. Then augmented reality. So in a general sense, augmented reality is on the other side of the spectrum of virtual reality, where in virtual reality we talk about a completely different environment from where you are right now. And in augmented reality, we are at the other side of the spectrum where we are able to see the current environment as is, but we also superimpose some computer generated content on top of that current environment. So in the video that you see on the screens is basically a very initial demo of Microsoft HoloLens, where the speaker or the host is describing thing like placing a piano in the world around you and able to interact and is able to interact with that. So the what is the benefit of augmented reality is basically you are in your own environment and it caters to applications that are a bit different from virtual reality. So virtual reality is focusing on applications where you want to be in a completely different environment from which you are in right now. One of the major areas being the entertainment industry. So games are one of the most major areas in virtual reality. So augmented reality kind of focuses more towards practical problems where computer generated or 3D models or different kinds of objects can be placed in your actual environment to help you in some way. So basically, let's say think of Google Maps, but think of Google Maps in your glasses. So if you're wearing some smart glasses and you're able to see the street view that you're walking in or driving on, and you're able to see the instructions right there in front of you, rather than having to take out your phone and then seeing where you should take a left turn or right turn, but you're able to see it right there in the screen. So this is something like a practical application of augmented reality. Next, we move on to mixed reality. So mixed reality uh, in the technical terms is generally a mixture of the real and the virtual world. There are two different like sides of mixed reality. One is basically where you are completely in a virtual world, but the interaction in the virtual world is enhanced or is supported by your physical world, by the world that you are physically in. So, like in the video that you see, on the left side is a completely virtual world. On the right side is an actual room that the person is in. So he's able to see a completely virtual world, but the sofa that he's sitting on or the piano that he's interacting with is in the real world. So there are objects in the real world that you interact with, but the things that you like, the impact of that interaction that you see is in a virtual world. So this is one way of representing mixed reality. The other way is basically a sense, in a sense, augmented reality, but with more interactiveness. So in the past 5 years, if you see mixed reality, like if you search mixed reality now, you'll see that it'll come with Microsoft mixed reality. Like if you Google search mixed reality, you'll see that it'll come around like Microsoft will be branding mixed reality. So what they did is basically they combined all their plans of VR and AR, which is basically combining their VR headsets as well as their plans of doing any kind of augmented reality with HoloLens, Microsoft's HoloLens, and they came up with a mixed reality platform. So what they did is they changed the actual meaning of mixed reality to market or to sell their own devices in the sense. And it took on for quite a while, where if you look at mixed reality headsets, so HoloLens is basically a mixed reality headset according to Microsoft. But in a normal sense, it's an augmented reality headset. Then there are actual mixed reality headsets from Microsoft, which are basically made from companies like uh, Acer and Samsung. These companies made mixed realities headset for a while. HP also has made. So there are various companies that make Microsoft's mixed reality headset. They still do. So try to understand the difference between what actual mixed reality is and how Microsoft marketed it as mixed reality and sold it. Moving on to something called the reality scale. So this is the scale on which all the things that we just discussed are defined. On the extreme left side is the real environment that you are actually in. On the extreme right is the virtual environment or any completely virtual environment. On the whole middle spectrum, we can call it mixed reality. A bit uh, left of your on the bit right of the real environment is the augmented reality spectrum. So if you see what kind of things that are possible in real environment, basically tangible user interfaces are possible in real environments where basically you have actual physical objects that you interact with or you work with. Anything that you want to do, if you have a demonstration, if you want to do trainings, if you want to learn anything, then you work with actual physical objects and not with any computer generated or any virtual simulations basically. So like if we go 10 years, 20 years back, any kind of defense training or any kind of medical training, all these things, although still 80%, 90% still being done in the real world. But if you go 20 years back, it was 100% real environment. Then coming to augmented reality can be broken down into two parts, spatial and see-through. So spatial is basically where augmented reality is presented to the masses or in a general sense in the environment. More than one people can see the same thing at the same time. So if you've seen, if you go to like the best example of this right now is if you go to malls, there are some AR displays in PVRs and stuff where they display brands and some other things, which is basically you done using AR fans. So like they are fast rotating lights, LEDs, which kind of display something specific, some branding, some smaller animations, things like that. So where a mass population can look at it, it feels like it's a hologram, but we are technologically we are not there yet where we actually can create holograms right now for a mass population. But there are ways of basically doing projected augmented reality right now. So one way is using these like fast moving fans and LED screens. The other way is there are projector based augmented reality where on some model or on some sand model or a wooden model, some projections are made and in a from a perspective of an audience, it looks like it is augmented reality. But like the actual futuristic version of this would be holograms like you see in movies like Iron Man and others. So that will be the actual futuristic version, which people are working towards, but we are still very far from actually achieving that. Then see-through AR is basically something where that we have achieved very well right now. Is basically something uh, in the sense that you and this is also possible through two ways. One is optical and one is through video. So optical basically means that you are seeing the real world directly from your eyes and the content the virtual content or the 3D computer generated content is augmented on top of this real world using some screen in front of your eyes. But you're seeing the real world directly through your eyes. And in case of video AR, you are seeing the computer like the real world as well through a screen, through a camera input, not directly through your eyes. So whatever right now you're doing on your phone for AR is basically video AR. And if you use any glasses based AR, which is either HoloLens or Magic Leap, they are basically optical AR. Then coming to virtual reality, there are again there's semi-immersive, which is things like which we talked about, like any desktop-based game that you play or mobile game that you play. It is VR, but it is semi-immersive VR. You're not completely actually in the environment, but you're still very immersive. Like PUBG is very famous to be one of the most immersive mobile games till date. Even though it is not like you're not actually immersed in the environment, it is one of the most immersive and one of the most engaging games till date. Then a completely immersive VR is basically where you actually have a head-mounted display on you, which is basically think of it like glasses. Like a lot of you might have all seen it, a lot of you might have experienced it at malls or at different places. Some mobile companies 4 5 years back, like Samsung, used to give free headsets with their mobiles. So maybe some of you have it with you as well. Uh, but completely immersive VR is one of the most exciting technologies right now, where basically sitting in your home, you can actually go anywhere, do anything, uh, experience anything that you want, interact with various environmental things, to do unimaginary things, basically experience things out of this world while you are in the comfort of your homes. And to enhance this experience of immersiveness, to enhance this immersive experience, to make it more engaging, there is a lot of research going on in the field of haptics, in the field of VR itself, like to enhance this experience, user experience. How do you actually make it more better? How do you make the user feel more comfortable in their own environment? So this is basically the complete scenario of what we call XR right now. So XR again also is basically two things. One is XR where basically X is just a placeholder and you replace the X with V, A or M and call it virtual reality, augmented reality and mixed reality. While the other end is where you call XR as extended reality. There, according to some reports from Intel and IBM, it becomes a confluence of other technologies like IoT and 5G and AI, which as a combined force becomes XR. So when we say extended reality, we mean other technologies have been integrated in this. Like we are not just talking about VR and AR. We are talking about a confluence of technologies like AI, IoT, 5G, and whatever futuristic technologies that have come up in the last few years. Then talking about how this translates to the metaverse, like what has happened in the last 1 year since Facebook changed its name to Meta, and why this, like how was Facebook sure that they bet their whole company or their whole fame basically on this side. So Facebook, like if you read about it or if you look into it, Facebook has in the past 10 years bought a lot of different small companies, starting from Oculus to uh, various small companies that are making hardwares for the XR interaction. There's a company, I forgot the name, which was basically making smart watches kind of thing, where like wearable for interaction in the VR and AR environments. So you can basically interact in the environment using your hand movements while wearing this special watch. So this watch was basically based on the technology of EMG, which is electromyogram, which basically takes your muscle movements and converts it into actual, like from your muscle movement, it can actually translate that into some real movements of your hands. So these technologies, like Facebook has been buying small companies since the last 10 years, and uh, they have rebranded Oculus. Oculus was a company which is very old and started completely in the field of virtual reality, and they made quite a good headsets before Facebook bought them. After Facebook bought them, they have completely changed the scenario. So Facebook believes that uh, the next step in the social media convention would be in the VR. So, like right now, what we are doing for social media, be it through Instagram or Facebook or uh, WhatsApp or any other platform, we are basically connected to different people through different platforms. And most of the platforms, like these three big platforms, are owned by Facebook itself. So it believed that the next step is to basically make it more immersive, make this social experience or social media experience more immersive. So that is why it changed its name from Facebook to Meta, where it kind of wanted everyone to shift their perspective from thinking that social experience is possible only on mobile screens to thinking that you can actually, at the comfort of your home, again be socially uh, accepted or socially be present at different places with your friends and do whatever you're doing in real life, but within the comfort of your home. So that is their major goal. If you look at the introductory video of Facebook when they actually announced these things. And also they have very good research in AI and other fields like IoT. So like their decision to actually change this name basically strengthens our belief or strengthens what a lot of people working in this industry have known for quite some time, that the next 10 to 20 years are going to be a booming industry for this booming time for this industry, for the industry of VR and AR. So moving on to what are some of the key advantages, we already discussed most of it, but it's immersive, it's engaging, it's risk-free experience. What does risk-free experience actually mean? Is like right now we are talking about social experiences and stuff, but think about uh, training for military and training for police or fire people, where basically the cost of doing these things, the cost of training them is very high, and you have to set up physical environments for them to train on again and again, destroy things, then build those things again. And using virtual reality and augmented reality, it is possible to do these training at very low cost, along with it being very risk free. So the people don't actually get hurt while training. Then there's very enhanced interactivity from what we are generally used to right now. Like if we look at the advancement that has taken place in the last 50 years, so 1950s, if we go back to that, most of the stuff was being done using pen paper. Then we moved on to desktop based systems in 1980s, 1990s. India was a bit late to that. We got it, like we made it mainstream in 2000s. Then we immediately switched 2008, 2007, we switched to mobile phones. Mobile phones immediately after 2, 3 years, we switched to smartphones. So like the uh, enhancement that has been there in the interactivity or how we want to interact with various kinds of content has been very fast. And this, like the next step is the enhancement in interactivity, where you want uh, your entire space around you to be your phone, basically your smartphone or your device, where you can actually see everything. And then last is entertaining. Like right now, if you see, 90% of XR is in the entertainment industry. It's mostly gaming and uh, other places where uh, it's in the entertainment industry. It's advertising, it's branding, uh, but mostly through entertainment only. So, what are the actual opportunities in this field? So, uh, there's there are two types of opportunities that we generally see in any field. One is industry or corporate. One is research. So industry, again, starting entertainment is the highest industry right now, but that is shifting slowly. It is shifting to the very first field that is taking up space is the training sector. Training and customer support sector is taking it up very fast because AR based customer support is like right now. If you must have used TeamViewer at some point in your life, which is basically a software that allows you to access some other computer or some other phone through remote access. So TeamViewer already has an AR based customer support system that they're working on. Like they already have one in deployment, and they're continuously working towards increasing the capabilities of that system. Training is one of the most popular areas after entertainment, where, like I talked about, we ourselves worked in DRDO in this aspect only, in the cognitive training aspect for the military and paramilitary services. And there are other training possibilities where, let's say, you are working in construction. So some new employees join you, and you want to show them what is what is going on, what is the current state, what their work actually has to be. So one way is that you physically take them to the site, you explore everything, you physically walk all the distance, take them to each place. And it is hazardous because it is an actual construction site, and new employees might not be aware of some things. They might do something wrong, and which can lead to something drastic or disastrous. While training in VR, like giving the first session in VR, will help them understand what is actually like what they have to do, what they don't have to do, explain them best practices and all those things. So this is not just being done in the construction or in this kind of an industry. Digital companies have started employing these methods for giving basically digital tours of their offices. Uh, a lot of companies are trying to start digital HR practices in VR, where they basically conduct interviews or try to give an experience of what kind of work the person is going to be doing through VR. So this is something that is catching up. But again, in the training industry, right now the 80% of the industry is dominated with military and defense kind of forces. This kind of services. Right now, the others are a bit slow to catch up, but they are catching up pretty fast. Then manufacturing is one of the most exciting things where this is being used, where basically uh, if you have some idea of 3D modeling or computer aided designing CAD, where people basically design these models on their computers, and then it goes to printing or cutting of the metal sheets, or actually designing something out of these 3D designs. But like with the use of XR, these can be enhanced. The experience of designing these things can be enhanced. So, like industry side, these are the four major sectors. On the research side, there are three major sectors. One is basically the advancement of the field of XR itself. There's very exciting research going on in the field of haptics, in the field of optical optical physics, to basically enhance the experience of the users by changing the type of lens that we use in glasses or VR headsets. There's a lot of interesting research going on in the computer vision side, which is a part of artificial intelligence. But this research is going on to enhance the user experience in VR and AR. And then there's a lot of psychology based research, which is something that we do, is to try to understand the human brain. Why this is more popular in this field is basically because uh, a lot of things that we want a person to experience, like hazardous environments and uh, things like, again, coming back to military training, it's not easy to implement those things in actual real world and still try to understand what the user is doing and trying to understand their behavior. That is why it's easy to implement this psychology based research in XR. And then the last is to basically support AI research. There are various ways that this is being done. Two most famous things that are being done is one is deep reinforcement learning research, where basically if you look at a company called DeepMind and another company called OpenAI, these are two big companies working solely on AI research. There, one is Google backed, the other is backed by Elon Musk, and their work is in deep reinforcement learning. So, what does reinforcement learning mean? Is basically a way of training generalized AI, where we try to train an AI, try to train a model which can do multiple tasks just by learning one task or just by exploring one task, and it basically learns like we learn, like humans learn or animals learn. The second most exciting research that is being done or being aided by this industry in AI is in the field of computer vision, where using the high fidelity that we have reached in the virtual environments, in the way that we are able to create virtual environments right now, we are trying to create synthetic data using this kind of this like using virtual reality and virtual simulations, where basically synthetic data is basically data that is not actually captured in the real world. It is either manufactured, it is either uh, augmented from the data that you are capturing that you have in the real world, or it is being created completely in a virtual environment. But this data is so realistic that whatever models or whatever AI is being created using this can actually be used in the real world as well. So these are some opportunities that exist out there, and like you can look for these things. It's very openly available. Next, yeah. So next, moving on to some project demonstrations. These are some projects that have been implemented as part of our research at either DRDO or at IDO. So this is a simulation which was basically developed by a WIP student. This is about 2 years back. Is basically a simulation where of uh, a cognitive test battery in VR. So basically, what we generally want in while we are training military or paramilitary personnel in general is basically we want to train them on these different factors: multitasking, susceptibility to mind wandering, tactical decision making, fatigue based error, situation awareness, things like that. We want to basically train them not to train them on these things, and there are two ways of doing that. One is basically a generalized test battery, a cognitive test battery, where we create very simple tasks that are not domain specific, that can be done by a student as well as a pilot, as well as a tank operator. And the results will tell us something about those people. The other way is to basically do specific domain specific tasks, which can be like, let's say for a UAV pilot, we do a UAV specific task and try to find out these things. So this whole setup was basically part of a generalized VR cognitive test battery, where their students from WIPS created uh, six different kinds of tasks in VR, which are uh, an enhancement of what has been done in the past on pen paper based tasks or computerized like desktop based tasks. So this is immersive VR based tasks, generalized tasks. So I'll just skip to show you some of the things that they've created. Next, moving on to something created by Mumbai University students while I was at DRDO. This is basically a simulator for a drone, which basically is trying to evaluate the multitasking capability of the user. So you have a task that you have to perform while there are while you are flying a drone, there are four different tasks that you have to perform. So like just now on the screen, you saw that there was some addition subtraction that came. So you have to do that. You have to maneuver to this a point in the map that you have to go to. Then there's a task of resource monitoring that is like blue, yellow. This thing that you see, this is something called as a stroop task. But like it has been performed as a resource monitoring task here. So there are four different tasks that the user has to perform at the same time while he's also flying the drone. So this is uh, something that is again created by students at DRD. Then moving on, because we are short of time, I think, to something that we have created at IIT Roorkee recently on a project to basically estimate workload in a driving scenario. So this is a long task of 15 minutes where a user has to go through four different scenarios of different tasks. There are audio challenges, there are visual challenges, and there are cognitive challenges. So this is a completely 3D environment built in Unity where you as a person or as a performer, as a participant is driving a car, yeah, in an environment where there's traffic, where there's automated traffic, there's pedestrians, there's some objective to what you have to do, where you have to reach, as well as some additional tasks where we are trying to understand what level of workload are you actually able to handle, and at what level of workload is your performance actually going down. So this is something interesting that we did recently. Then this is a real-time cognitive state monitoring, which is basically this is one of the major. This is where we show a confluence of different technologies, like I talked about how VR and BCI and machine learning are coming together. So the goal of this research or of this project is basically to understand or to implement uh, real-time monitoring of a person's state, where we are monitoring six different things. Let's just skip to that part, where we are monitoring six different things: workload, situational awareness, attention, engagement, fatigue, and stress, while the person is performing some task in VR. And we are doing this through something called EEG, which is electroencephalogram, or if we talk in general terms, this whole setup can be called as BCI, which is a brain computer interface. So this is one of the most exciting research going on right now in the field of neurotechnology, uh, which is a confluence of artificial intelligence, BCI, and VR. So on the top right screen is your VR environment. On the top left, top bottom, sorry, the right bottom is EEG data, which is basically your brain signals. On the left is actually uh, a VR, an AI-based classification of six different states while you are actually in the VR environment. And this actually works on a domain specific task, like which is this driving task, and a generalized task, which is this stroop task, this basic stroop task. Some task is there which basically is used to record your executive function. So that's that was some of the demos of the projects that we have done in the recent time. Then let's move on to talk about some of the technologies that are involved in the development, some of the tools and technologies that are required whenever we talk about the development of XR. So there are three key components: 3D modeling, a game engine, and the actual XR devices where you deploy the anything that you make. So 3D modeling is very common. This is not something that is recent. It is something that is very old. It has been done in the past through various tools. Like these are very old tools: Blender, Autodesk Max, Autodesk Maya. These are old tools which have been used in the past to do various 3D modeling work. Like it's not specific to VR AR. It has been used in game development. It has been used in the animation industry uh, to create movies, to create films. A lot of those things have already been done. So there are four major things that you can do in using these tools, which is modeling, texturing, rigging, and animation. So modeling is where basically you actually create the 3D models. So let's say, let's talk about creating a chair with wheels on them, like a chair with wheels on them. So the very first step is to create that chair, put the wheels. All of these are separate components that comes under modeling. So texturing is basically applying paint on this in a sense, or in the sense of chair, you would want to wrap it up with leather or some other kind of uh, cloth or something, like basically wrapping up or covering it up. So that is what texturing means. Rigging is basically the capable adding the capability to the model that you have created to actually animate or to actually have some physics that can be applied on it. And animation is basically trying to actually animate those things. So like if you want to move the chair in an environment where the wheels are actually moving and while the chair is moving, so that is where animation and rigging helps. And the tools that are used for this is Blender and Max and Maya. Blender is an open source free to use tool. Max and Maya are paid tools from Autodesk. Then next major component, and this is something that we'll majorly focus on in the course, is game engines. Game engines are responsible for four things again: physics, scripting, user interaction, and gameplay. Physics is basically the core of the game engine. Physics is something that the game engine is actually providing you so that you don't have to write your own physics. So what actually physics is defining what time scale your game is playing at, what gravity is applied in your environment, how much force is applied when you touch an object, when you push an object, things like that. So this is where physics comes in. Scripting is basically actually activating something when you do some interaction. So any kind of coding that you do in using game engines or in games or in XR development is basically called as scripting, where you try to script behaviors. User interaction and user interfaces are a major part of XR, where how you interact with the world that you have created or how you interact with the objects that you have created uh, are a major part. And then gameplay is basically like an old gameplay mechanics are have been here for the very long, which basically includes things like how the rules of the game, how the scoring is done, what is the game end condition, what is the respawn condition. If you die somewhere, where do you respawn from? So basically defining the actual rules of the entire scenario that you're creating. There are there are two major game engines, Unity and Unreal. I've also included the Godot game engine because it is an open source game engine which is popular but not very much used in the XR industry. Two major game engines that are being used are Unity and Unreal. There are personal preferences that people choose, but if you are generally, from my personal perspective, if you are from a programming background, if you know basic programming, then Unity is a better tool for you. If you are from a design background, you have worked mostly with design tools, then Unreal is a better fit for you. Obviously, there are other pros and cons, but eventually Unity and Unreal uh, right now, as companies are fighting with each other a lot and are providing almost the same things. Then finally coming to devices, we discussed already a lot of this, like different kinds of AR devices, and VR is basically right now almost every VR device is immersive VR device, and phones and desktops. Let's just assume that they're already there. So in VR devices, like I've put 5 images. This was basically to show a transition of how it has changed. If you look at the first image, it is a Google Cardboard, which was 15 years back that Google came up with. Then they came up with something called Daydream, which was a phone like where you can place your phone again, but it was a more complex system. You can interact with the phone in this headset itself. Like this is an image of Samsung Gear VR, but similar to Google's concept of Daydream. Then there was the PlayStation VR. Then there are tethered VR headsets like HTC Vive or Oculus Rift. Uh, and in the very recent times, there are untethered VR. So tethered and untethered are basically tethered VR basically means that there's a wire or something that is connecting your VR headset to your uh, system, to a laptop or a desktop or some kind of a system where the simulation is actually running on the system and not in the VR headset itself. But in the last 5 years, a lot of standalone VR headsets have come out. One of the most popular ones in this is the Oculus Quest, again from Facebook, Meta now, which is like a very cheap, not very cheap, but still it's comparatively very cheap compared to other industry standards that are available right now. And it is a standalone headset which basically runs on a core Android platform. So if you create APKs which have VR interactivity in them, you can run them on Oculus directly. And they have a app store of their own. They have a whole ecosystem of their own. They're creating an whole ecosystem. Like that is what Meta is pushing, like the metaverse that they're pushing. They're creating a whole ecosystem of their own. On the right side, we have augmented reality devices. They're mobile based. There's glasses based. So this is like this image is Magic Leap. This image is Microsoft HoloLens, and this is a general image of mobile based. So there are two Indian companies right now that are competing in the market. One is Geo Glasses. A lot of you might have heard of it. They kind of promised 2 years back in their AGM meeting that they'll come out, but they are in the running. They are actually they. I have had a few meetings with GeoGlass team. They are creating an okay device. Like it's not at par with HoloLens or Oculus, but they are creating a mixed device where it can work for both augmented reality as well as virtual reality. But it is offering a lot of exciting avenues for low cost systems. The other company in India is called Anya Lens, which basically makes industry standard VR headsets. So they make their own VR devices and they are making uh, training modules for different industries right now. So they are, I don't think they're selling their VR headsets to consumers right now, but they're costly. They're in league with HTC Vive and industry like those kind of headsets right now. So that is a basic introduction of everything. About a very general introduction in the domain of XR and this VR AR domain. Next, we talk about like what the actual course is going to be and like what we'll be learning, what you will be learning, and things like that. So there are the courses going to be in 30 sessions, and it is going to be divided into six major domains, like five major domains. Sixth one is just a smaller domain. It's going to include introduction to Unity. Unity has scripting like the programming languages. The language that Unity uses is C Sharp. So there's going to be an introduction to C Sharp and how to use that with Unity. There are some basic things that are included in Unity, like effects, animation, gameplay mechanics, how to implement those things in Unity. Then focusing on VR development, deploying whatever you make, and then AR development. And then finally, as a bonus, there are two things that I want to introduce. One is using Unity for AI in RL as well as computer vision research. Like I told you, two most exciting things that are going on right now. And then there's a platform called Spark AR, which is a platform from Facebook uh, to create filters and stuff like whatever you see on Instagram right now is basically created using Spark AR. It is very simple to do. This is something that is interesting and easy and has a lot of potential in the job market right now. So this is something that we'll cover. So uh, like the actual importance in the job market right now, if you right out of college start applying to jobs, they'll ask you to show a portfolio. It's not just in this domain, it's not just in the XR domain, it's in any job that you apply to. After graduating, if you apply for any developer role or any app development, software engineering, any role, unless it is at companies like Amazon, Google, Facebook, Fang. Other than that, uh, all they also require you to have a very strong portfolio of things that you've built. So I'm assuming that you already have a portfolio of softwares or apps that you build, websites that you build. So this is something that you can add to your portfolio. In the course that we'll be doing, we'll include three basic games, one VR game and one AR game. Games in the sense like it depends on what you want to build. I'll have a basic structure ready, like a basic idea of what can be done, but it's up to you how you enhance that, what how you show that. You can create a game, you can create a simulation, it can be anything. But this is generally the idea right now. Then internship opportunities. I'm at IIT Roorkee. I have my own company called XR Labs. So these are like direct opportunities that are available. Then we have a lot of connections at different organizations like DRDO and IIT Delhi and other IITs, and a lot of different startups that are working in this domain and looking to hire people. Like they start generally right now, anyone who hires starts with internships and then generally converts that to PPOs and generally gives you an actual job after that. So there's a lot of options in this domain as well. So yeah, that's all from my side. Thank you. And you can connect with me on LinkedIn. This is my email ID and my phone number. You can reach out anytime you want. Thank you. Can take queries now.
Thank you so much, sir. It was a truly wonderful. It was truly wonderful that we get to have you as our instructor for the next few days and lending your time and expertise to us. So we do have a few questions here in the chat. I'll read them out to you. Pranav here asks, where should we start from, Unity or Unreal?
So, like I talked, generally, if you're from a, like, this is my personal experience or personal perspective, that if you're from a programming background, you start with Unity, and if you're from a design background, start with Unreal. Learn one engine, the other engine is very similar. Both are very similar, both are providing the same things. The scripting background is different. Unity is C Sharp, Unreal is C++. If you are from a programming background, why I say that you should, if you're from a design background, you should start with Unreal is because they provide something called as blueprints, which is basically a flow diagram kind of a thing to actually script whatever behavior you want to script. So whatever you're doing in code, you can actually create flow diagrams in Unreal Engine for that. So generally, if you are a developer, if you are from a coding background, you would require more, you demand more control from what you're building. So that is why it's better to start with Unity.
So for example, so now it's my question. I happen to be more towards design. I model stuff in Blender. So as a person who's not great at programming, that great at programming, would you recommend me to go towards Unreal or Unity?
If you have zero experience in programming, then Unreal. If you even if you know basic concepts of programming, then best to start with Unity. Unity has a the learning curve in Unity is not that steep as it is in Unreal. Once you learn the basic concepts of what different things mean, what how physics is implemented in games, what gameplay mechanics is, how lighting is implemented, how effects are implemented, what happens when you change certain things. Once you learn these things in Unity, similar concepts can be applied in Unreal. So if you have zero experience in programming, then start with Unreal. Even if you are aware of programming, if you know the basic concepts, OOPS concepts, basic any data structure concepts, then start with Unity. The learning curve is very easy in Unity.
Thank you, sir. Then now Sagar has a question, which is, how is machine learning integrated in XR?
So there are different ways that it generally is integrated. One, like I showed one of my research where it's a confluence of three different things where a VR environment is involved, brain data is involved, and machine learning is involved. So machine learning is being implemented on your brain data while you're doing some task in VR to evaluate something. So this is one way. The other way is deep reinforcement learning, where the concepts of machine learning, like the agent, whatever you're training, is learning in a simulated environment, and that learning can be actually implemented in a real world scenario as well. And the third scope is basically to create synthetic data, to generate synthetic data. Uh, for any kind of computer vision or natural language processing kind of things. So these are three major domains that I can think of. There are obviously a lot of other research as well. A lot of machine learning research is going on in enhancing the XR experience as well. So there are things like foveated rendering or uh, focus-based rendering, which basically are you employing machine learning algorithms to render whatever you are seeing better. Uh, in contrast to a normal scene, you will be able to implement or render things better at faster rates and see things much better.
So, okay, there are quite a few questions piling up, sir. I'll just pick a few which seem relevant. So, Kushagra
Sure.
asks, what are major companies for the role of game development as a career?
Uh, so, like for game development, there are lots of small companies in India that I know of, which basically offer game development as a service to different clients. I don't know if they have their own games. Like this is again, I'm talking of India, but major companies, one of the major companies right now is Ubisoft, which has offices in India in Pune. They hire a lot. They have been hiring a lot. They hire a lot for XR roles as well as for game development roles. Other is Epic, which is basically the creator of Unreal Engine as well as Fortnite and a lot of other games as well. So Epic hires a lot from India these days. These are two major companies that I can think of right now, but there are a lot of small companies which are Indian companies that hire extensively for the role of game development.
Okay, so I had another question, sir. For example, if I wish to approach Ubisoft or Epic, for example, what key things are they looking for in my resume? For example, if I did start as a game developer, what key things are they looking at?
So there are like several different roles in game development. Few major roles are a game programmer, level designer, game designer, things like that. So like from our background, like if you're from a computer science background, I'm assuming uh, you have knowledge of programming, and if you're interested in a programming or development role, then you generally join as a game programmer. So where they are looking for whatever a software development uh, role will look for, exceptional coding skills, exceptional problem solving skills, good data structures, and all those general skills that you would apply for while you are applying for any software development role. Apart from that, they'll be looking for how well, or like your portfolio of games that you've created, what is the complexity of uh, codes that you've implemented, how well optimized your codes are. So, like in general, it depends on what, uh, like let's say Ubisoft is hiring, like that's a big company, so they generally hire for uh, even within one team, they will have multiple people work in the same role. So they are not concerned with your multitude of skills. Like they're not concerned if you have if you can do 20 things. They're concerned with one skill that you can perform exceptionally well. But if you look at companies which are hiring in roles for, like let's say game develop as a proper game developer, or a Unity developer, or an Unreal developer, and a lot of companies right now are hiring for hyper casual games. So for that, they will require, like software development. Basically, basic software development is a necessity. Understanding all the concepts, whatever you're learning in software development is a necessity. Apart from that, they'll require, these kinds of companies will look at how many more skills that you can add to their team, because they generally work in smaller teams. So they look for, if you have more than 10 skills that you can actually add to their portfolio. So these are two ways to approach.
Well, thank you, sir. So on behalf of the Institute and the organizing team of this session, I would like to extend a very hearty vote of thanks to Mr. Vishal Pandey, Professor Dr. Supriya Madan ma'am, Dean BSIT, for providing us students with an opportunity to enrich our skills and fostering our growth for today's event. We are grateful to Dr. Dheeraj Malhotra sir and all the members of the organizing team for their excellent logistics support and guidance. I would also like to thank our audience of young intellects for their patient hearing and undivided attention towards today's session. So I would request them that the form is live, and I would request you to turn on your cameras once again for a final picture. Okay. So thank you all for cooperation. I would now request everyone to fill the feedback forms through the link provided in the chat. Everyone is requested, as told here, to upload a photograph of themselves while attending the session within the feedback form. Thank you once again to everyone for being part of this session, and we look forward to be part of this course with Sir. So thank you, everyone. This was it, and we look forward